Good morning, Shiraj. Good
Hello,
morning.
good morning.
How are you doing today?
Yeah, I'm doing well. How are you doing, sir?
Doing just fine. Thank you for asking. Very glad to see you join us today, and I hope everything is fine on your end.
Yes, everything is fine. And
All right.
it's been
It's
almost 2 years. I'm here again. Uh,
okay. I welcome you very warmly, and I hope everything's gonna be fine doing that. I just sent you the authorization to share your screen, but please wait until after we admit everybody. So if, with your permission, I will admit the participants at this time, and after we into presentation. That's okay with you?
yeah, it's okay. And just to be sure, like, is my sound clear enough?
It is clear, super clear. All
Okay.
right. Where are you exactly?
Right now I'm in Dhaka, in my native, like Bangladesh. And from
Oh,
here,
Bangladesh. Okay.
yes,
Welcome, brother. So let's get started. Admitting everybody this moment.
yeah, total, how many students are expected to attend this?
We actually invite everybody, so we are not sure exactly how many are gonna be in attendance, but they have begun to join us. Ladies and gentlemen, thank you very much to decision to be with Atlantic International University at this time. I am Dr. Franklin Valsine from the my face. You can see the smile, you can see the joy. This is very, very epidemic. It is my routine every time I have this chance, honor, opportunity to welcome you for our live class sessions. Today, our presenter is going to be Muhammad Al Fashal Shiraj. He's an expert in the arena of robotics. But just before we get there, it's usually a pleasure for me as well to honor the first participants of today. We are looking at Alvin Guefeu, Stephen Kweku Dadzie Forson, Barthélemy Cabaret, Dale Carnegie and Ismael Adib. That Ismael. Everybody, Dr. Adamu, Anosike Marcus, Khan. We are admitting at this time Kennedy, Mangi, Alfenia Richard, all those beautiful people. Very, very glad to have you on this Monday, the first business day of the week. Thank you again for being with AIU for another presentation of our live class series. You can see my introduction on the chat box. Uh, I hope everybody understands that we are getting in the arena of robotics. We're talking about a field that is gradually gaining momentum, gaining speed. We are using robotics virtually in every field. But that is not definitely my field of expertise. I am an education specialist. But fortunately, we have Muhammad Al Faisal Shiraj, the true SME, subject matter expert in this arena of robotics. Ladies and gentlemen, please join me into welcoming Professor Muhammad Al Faisal Shiraj. Good evening. uh, Siraj.
Yeah, thank you. Thank you everyone for joining this class. Hope everyone can listen to me. Am I audible? Like everyone
Your
can hear me?
audio is perfect, 10 out of 10.
Okay, thank you. So it's my pleasure to uh, come here for the second time. It's been almost like more than 2 years now that I was here for a session for CAD design. Now, I don't know if anyone from this session was back in that class, but no worries. Today I have come here to share a totally different topic that is on robotics. And the title that I have chosen is kind of like a bit, I would say, like eye-catching, that what is not robotics, and it should have been what is robotics, but why am I giving a not before that robotics? And I'll show that in the presentation today, that actually we have a lot of misconception about robotics, and how these misconceptions are misleading us to understand how the robotics uh, s- scene will become in the future within the next 10 years. So a lot of the misconceptions, if I can, uh, yeah, if I can give you some insights of what is happening in the current industry, maybe these misconceptions will go away, and you guys might start thinking about your own future surrounding the robotics business. So can I share my screen? So,
Yes, we are all ears and can't wait to see your presentation, Mohammed.
okay. So I'll just, uh, I don't know if it's, yeah. Can you see it?
No, we don't have it as of yet.
Okay. Share it. Okay.
Okay, it is coming on gradually.
Yeah,
Uh,
I'll just open the slide.
okay,
What?
all right, everything is ready to go.
Okay. So do you want to wait for more students, or can I just start?
No, let's get started because, we have rules, so let's get started. They will be coming gradually.
Oh, okay. So no worries. So the start, I will give some introduction about myself, so that uh, there will be at least 5 minutes people can join within this time.
Okay.
So, so to know like how I can share about robotics, you guys need to know a little bit about what I have been doing for the last few uh, or at least for the last decade, what I have been doing. So I was actually studying in Australian University, Swinburne University of Technology in robotics and mechatronics. And from that time to now, it was like almost 9 to 10 years journey. And first 4 years was me trying to learn, and now for the last 5 years to 6 years, I have been trying to apply all those things what I've learned into like real industry arena, you can say.
Very
And so
impressive.
for the first 3 years, yeah, so for the first 3 years, I have been freelancing on one of the top like platforms in the internet, Upwork. And after doing better at that scene, I tried to transition to a entrepreneurship journey, and then I started my own startup in the last 3 years. I have been running them, and right now I have a team of at least 10 people. And later you guys can check out my website. So what I want to show is that we have been doing a lot of works related to robotics, and that's why what I can share at this uh, like at this even at this age, I think it will be really valuable for all of you here at this lecture. So these are a few projects that we have done within the last uh, 3 years. And here are more some of the projects that we have been doing. So the both of these slides are showing robots which are general purpose robots. Some are like mobile robots, and some are using like robot arms or hands. And in the next slides, I'll be showing more about those things. And so kind of like this sums up the introduction of what I have been doing and what my company has been doing for the last 3 years. So today's topics, I don't know if you guys can see it well or not. So if I say that the summary of today's topics are divided into four sections. So first, I'll be talking a little bit about fake robotics. Why I'm saying fake robotics nowadays, like in internet, a lot of things are spreading so fast and people are believing whatever they're seeing. So people should know like what is fake and what's real. So that's why I want to demystify the myth of some things that has been sold in the name of robotics, but it's not. And then I'll be talking about the real robotic stuff that's going on right now in the world. And then I'll also show that what complexities are like, what are the behind the scenes things that's going on. So that complexity I will show you. And also at the end, I'll show the opportunities in robotics. So now we can start with the first slide. So the internet, most of the internet people are teaching us and they're saying that robotics is a really easy thing. And but actually what they are actually saying that it can be easy like the pictures shown in this, that you just attach a battery to a motor or to just some lights or fan and then you have a robot right there. And yeah, it can be a robot for maybe a different age group. Maybe for a 4-year-old, this can be robotics, but in truth, that's not robotics in total. So there is another misconception that you have some kind of Arduino and some motor and sensor, and there you go, you have a robot already. And yeah, right now there are even some universities where the students are getting these kind of projects, and when they are playing with these kind of projects, after achieving one of them, they think that they already has built a really big robotics system. But in reality, it's not. And also, there are a lot of YouTube videos available right now, and some people can watch this video, and within 2 days, they can build what has been taught in the YouTube videos. But we almost forget every time to understand that what has been done in that YouTube video was maybe like a year-long work, and they simplified it and brought it into the YouTube so that you guys can do it within 2 days. But that's not going to give us a leverage in the robotics business. So that might give the video the YouTuber a leverage, but not the viewers. So for the viewers, I want to share that what actual robotics looks like. So this is one of the scenario, like two robots are working together. So we have on the left a robot, like two robots are over here, and one of the robot has two arms attached to it. Like it's like two hands attached to it, and that two hands are catching one bag. And here the robot is using computer vision and also precise grasping ability. The gripper needs to have that precise ability to grasp the bag because the bag is not a solid structure. And on the right hand side, you can see that the robot is trying to flatten and fold a cloth. And these tasks may be really easy for a human being, but for a robot, it's really difficult. So here I have on the left, I showed some kind of comparison in what kind of technologies are used here and what complexity of all hardware, kinematics, computer vision, and dynamics and control has been done to achieve this feat. And if you guys note that, and then later you will understand that the next slides will go, it will just increase significantly. So the hardware complexity will change over here. It's almost 95 now. And the kinematics has a bit reduced, but the computer vision also reduced. But you can see that the hardware has been really complexly done over here. And watching the video, you'll understand why I'm saying the hardware design is complex. So this is not just a normal Roomba robot, or like we know that the factory cleaning robots used. So this one was like It was like a concept at first, and some companies right now is trying to make this thing work. Like if they want to climb stairs, it can be easily achieved using this kind of mechanism. And the work done in the hardware side and the mechanical side of it is really huge, you can say. So I wrote two, three notes over here. Like this kind of robots has to navigate the whole house. And that's a really big challenge a robot needs to understand. It's not like randomly navigating. It has to be planned navigating so that we don't consume that much battery. So the battery consumption is very like efficient. And when it navigates throughout the whole house, it also needs to store a data where in the house I have the maximum amount of dust and the waste like put out. So when we know that gradually the robot only goes and spends most of its time on those places rather than the whole house. Like even like for our human brains, when we try to understand that, like which part of our rooms are really dusty and a lot of uh, things can be there, and we try to register in our mind that we will go there, and if we can clean it, the whole house will be cleaned like 90%. So that thing has to be also fed into the robots by AI and data science, that kind of things. And for the climbing, you can see that the robot locomotion or locomotion, you can say, is the movement of the robot is really complex over here. And for that, a lot of linkages design has to be done. And it's really collapsible. You can see it's still the size of the Roomba robot, but when it's doing the thing, it's trying to be like a giant robot, but in reality, it's again collapsing to the original shape. And the second uh, thing that I want to say show is about robot dog. So this kind of quadruped robot with four legs is usually called a quadruped robot. And here, the previous slide, you saw that these are moving by wheels, which is really easy to move. But when we are trying to move by legs, it takes the game too much high complex. And that's why in the dynamics and control, you can see almost 90% work has to be done. And here, the localization, that means the robot should always know that where he is, and he should go back to his place for self-charging. So I'll just play the video shortly so that you guys can, while I talk, you can understand that how complex tasks this robot can do. So usually, this robot, they are planning to use it in industries where human inspection is obviously not enough. And this kind of robots can see, you just saw that like it has like heat vision and it's checking that if everything is correctly placed or not. Or if there is something wrong, then it can send a signal back to people that are within the premises, and they will come back and check and maintain the whole hardwares. And you have seen that it can also maneuver the stairs easily. For the previous robot, it was really difficult to maneuver the stairs, right? But for this robot, it's nothing. So some robots get advantage in some of the areas where other robots get advantage in other areas. So here you can see that these robots are coming back and trying to self-charge. So this is like a docking station. And after they are self-charged, they go back again and they are working like endlessly, which a human being will not be able to do. And in countries where uh, like there are human worker shortage, they will try to utilize robotics more than anything. And there are there are even other benefits, like these robots can also like give a real-time data, and the real-time data, they just don't give it, it's directly stored, and for like months and years of knowledge, the industry will get that what problems we are facing daily and how we should uh, change our engines or our like whole machines so that we don't get these kind of problems again and again. So a human being might register that, but we don't necessarily understand that the what's the long term game of the whole industry. So that's why we fail to register the things, and we don't usually give that much feedback. But the robot will give continuous feedbacks. And here is currently what I'm showing is one of the recent technologies. Like the previous robot dog that I showed, it was like the startup first launched in 2017 and still running, and they're improving day by day. But here, what I'm showing, it's like this one was launched just 2 or 3 years ago, and you can see a figure one plus OpenAI. And I guess everybody in the room knows what OpenAI is or ChatGPT is. Now they are trying to make the robot more mobile, not only like a robot dog, just like a human. So there comes a humanoid robot, and apart from the humanoid design, they're trying to integrate it with things like ChatGPT, or like you can say generative AI. So where uh, right now what we do with ChatGPT is we are just talking with them and we are trying to get some advice from them. But in the future, when the robotics will merge with these AIs, the robots will try to understand what we are saying to them, and they will try to do the task uh, with those prompts, right? So we will say that if you see the video or the demo, you can already understand that how much complex it can do. Firstly, you guys have to listen to this. So please tell that if you can hear the video sound or not.
Hey, figure one, what do you see right now?
Thank you.
I see a red apple on a plate in the center of the table, a drying rack with cups and a plate, and you standing nearby with your hand on the table.
Great. Can I have something to eat?
Sure thing.
Great. Can you explain why you did what you just did while you pick up this trash?
On it. So I gave you the apple because it's the only edible item I could provide you with from the table.
Great. So, based on the scene right now, where do you think the dishes in front of you go next?
The dishes on the table, like that plate and cup, are likely to go into the drying rack next.
Great. Can you put them there?
Of course.
All right. So, how do you think you did?
I, I think I did pretty well. The apple found its new owner, the trash is gone, and the tableware is right where it belongs.
I agree. Thanks, figure one.
You're welcome. If there's anything else you need help with, just let me know.
Okay, so this video will give everyone a little bit of understanding that what kind of complex works can be achieved by robotics. Although robotics is not that much easy, so that's why the robotics researchers always say that it's taking more time to bring robotics to the stage where everyone wants. But for AI, it was really easy. AI just is working itself to develop uh, his generative ability. That means AI is working himself to make him better, but robots can't do that because it's on physical and it has a lot of constraint physically. So there are a lot of things that we need to take care of if we are trying to develop a robot. And just like this robot, there are a lot of different robots that will be developing within this next 10 years, and robots will get into our lives just like smartphones did. And it's a very big uh, bet that a lot of people are taking, and they are taking it for a reason that the robotics will become more cheaper. That means getting or buying a robot will become more affordable, and people will then start buying robots more. And these robots can solve a lot of general tasks that we usually need a person to do. And obviously, that's a question that then what people will do, like if all of our works have been done by robot, right? So there are a lot of debates going on around this fact that what we will do if everything is has been done by robots. So for years, we are getting the same answer, and the answer is that we'll do more engaging activities, or activities that makes us more delighted, and also like thrilled, and we'll do things that matters the most. We'll spend more times with our families and work a little less. But I don't know, like that's what I've been hearing, but it's very hard to predict the future. Right now, if you see that when we are using smartphones, the smartphones can do a lot of things, but it's very hard to tell that smartphones has like 100% made our life easier. Yeah, on one end, it's making the life easier. On another end, it's making a lot of things more difficult. So people also need to find out how they can navigate using the robots in the future. And when they do, the robotics industry will grow immensely. So the next thing that I actually want to show now, what I showed till here was easy because this was just a demo of few robots what's right now available. But what I want to show is that like when we go to design robots, what are the challenges we need to face? So here you can see 1, 2, 3, 4, but actually there are at least more than 10 to 20 problems that we have to solve for each departments. And I have categorized the department into four, like one is hardware, one is kinematics, one is dynamics, and one is software. Do you guys remember that I gave a technology complexity graph over here showing the percentages? So that's what I am trying to show in this next slide. Okay, sorry for that. Okay, now here I'll just give you a little bit of technical touch. I know it might be a bit difficult to grasp right now because a lot of technical know-how needs to be understood before understanding what I'm showing you. But I'll try to make it as easy as possible for you guys to understand. Okay. So the first is precision machining and tight tolerances. This one would be easy for a lot of you to understand. Let's say if I have a pen, for example, over here, and the pen has a cap, and if the pen cap is a little bit tighter, I'll not be able to just fit them, right? So like that, a lot of parts are there in machines where if the tolerancing just goes wrong, the machine after the whole part is machined, and each part machining might cost $100 to $500. And after they machine them, and if they doesn't fit, then the whole thing has to be done over and over again until they fits. So a lot of time is taken over here to understand like how much tolerance will be uh, okay, so that we have the least amount of cycles that we are doing to get a fit ready part. And in our whole robotic machine, just like the ones that I showed you in that, like there are so many things that has to have like fit. Like there has to be like tight tolerances and interference fit somewhere. Somewhere there needs to be loose fit. And all those things has to be totally understood. So the whole mechanical design part has this very big roadblock. Once this is solved, the road is a bit clear. But when that is clear, then people feel a lot of different issues like thermal issues. Like let's say if a robot is getting more heated inside, just like you guys are using maybe a laptop or a computer, like when the computer is getting heated up, there has to be a lot of fans so that the fans are taking air in and also trying to circulate the air so that it's getting cooler and cooler, right? But uh, when I was using the first computer in 2000s, yeah, 2001 or 2002, that time the design was mostly covered. Like if you remember, the casing was not having that many fans because that time the hardware was also not that much complicated. And as we go in the future, you'll see that a lot of complicated hardware is used in the computers, and we'll be using more fans. But for robots, it's very difficult because if you are using that many fans, you will not have a really beautiful robot like this. So it's a very big challenge that you need to also think about the aesthetic and also about the power management. Okay. So third thing, the very big challenge is the sensor reliability. So what is sensor? Sensor in one, if I explain sensor in a way, is that we have a lot of sensors in our human body. Like we can sense the touch. We can sense like if there is anything in front of us. That means our vision is also one kind of sensing machine. Then when we are taking something in our tongue, we can understand the taste of it. That's also kind of a sensing machine. And a lot of sensors are there. And remember, like let's say when we have a fever, and at that time, it's very hard for us to like understand if this tastes really good, right? You guys can understand when we are sick, we are not being able to understand that if this dish tastes really well or if this is tasting a bit bitter. And because that time our sensors of the tongue is not working. And in same way, if one of the sensors of a robot goes wrong, then the whole robot will try to have different actions for a different kind of prompt. That means I will ask him to fetch the apple, but it will fetch me a ball. So that's why sensor reliability is very important. And the last thing is that since we are talking about hardware, so I was only talking about hardware over here. And in hardware, you guys know that the cable routing is a really big problem because even in our small offices, if we have cables laying around us, we feel really annoyed, right? So we try to manage those cables, try to hide them where we don't feel like overwhelmed. So in robots, that's also a really big problem because a lot of sensors, a lot of motors, and a lot of power supplies are used. And while giving all this connection, we also need to make sure that we can hide these cables and in a way that we don't see the ugly parts of robotics hardware. So these are only 4 challenges I have mentioned over here. In reality, there is a lot of different challenges, but I have not mentioned because the class is a bit shorter. So, Dr. Velsin, can you give me like how many minutes are left for this so that I can understand that how much I can talk?
More minutes
Uh,
to go, but we still can,
how
go
many? How many?
overboard.
I couldn't hear that. Can you again repeat?
Okay, we have still go overboard, 5, 7 minutes after the allocated time.
Oh, okay, okay, okay. So is
Okay.
my time, is my voice clear, or is it like getting a bit distorted for unstable connection?
No, you're doing just fine.
Okay, all right.
Okay.
So the next slide is kinematics and mathematics challenge. Now here things gets more like academic, and that's why people actually needs a really big degree to be an engineer, and where they need to start from engineering maths, trying to understand the mathematical complexity of each machines. And since these machines are moving machines, it's not like a static machine. there is a lot of motion tracking needs to be there while we are just calculating with mathematical equations. So one of the most difficult parts over here is that we call it inverse kinematics. So when we were in our third year, I remember that that was one of the most challenging things, and like we somehow passed that subject because it had a lot of complex maths and also like dynamics and mechanics included within robotics. And so we faced a really big challenge over there. So here, so the first one, what I am saying is that inverse kinematics, what does it actually means? Okay. So let's say this is my hand, and this hand is a robotic arm. And if I try to pick something, I need to know what is the location of that object. And if I know the location of the object, and if I know it already, so I can give some kind of mathematical values to my motors so that it can reach and pick up that object. And where we want to put it, I have to again give the location to that, and it will go there and put that object. So in order to know that, we need to know a lot of variables. And for that variables, you guys know that to solve variables, we need an equation. And here there is not only one variable, like how many joints you'll have. Like some robots have 6 joints. So that is called like 6 degree of freedom robot. Some robots might have 4 joints, that is 4 degree of freedom robot. And more joints it will have, it will need more complex mathematics. So like you guys can guess that almost like for 6 degree of freedom robot, the mathematics like we have like reports where like 5 pages were needed to solve the inverse kinematics, like 5 pages of equations, like one after another. So that's how difficult it is. And then even that there are some like abnormalities, like even you're going in the right track, but you'll face some other challenges like nonlinear transformation and singularities. Like some in some robots, when it goes from 6 to 7 degree of freedom, like there are some results that it can be like infinite, like there are like infinite combinations that it can achieve, and that time robot doesn't understand what to do. So for that, those kind of singularities, like we need to be writing a really clean code so that we can take care of this kinematic challenge. So in that clean code, I can give you some example, like it might prompt one of the safest path rather than like being confused with like millions of paths it can choose from. So we have to like hard code that information before like the robot start doing something like abnormal. And the third challenge that people need to face is that real-time trajectory optimization. Like we have to not only take care of from one spot to another spot, like we pick up and we just put it down. We also need to understand what it might face while like putting that thing. Let's say if we have an obstacle in the middle, we need to plan that, okay, we need to avoid that and then go up to avoid that obstacle. So that's why the trajectory planning is also very important. And that is a different level of mathematics. And we have to, for each points, there has to be a different formula. And just like that, the fourth problem is the accurate world frame calibration. Now, the thing is it looks really clean on papers, but when you go in the real world and try to test it, you'll see there are some uh, tolerances, or there are some like values that's not making sense. And that's like, we need to calibrate it, like how much error we are getting always, and we need to offset that error to start with. And that's why accurate world frame calibration is a very important part for reaching the robot mathematics, like very like 99% accuracy. We'll not say that it's like 100% accurate, because a robot will have some little errors. But as we go in the next 10 years, robots will become more efficient, and people are working on precise robotics a lot, and they will be performing surgeries using robots. So you can already guess that how much precise robotics will become. So right now I have seen some videos, those are like demos. So I haven't put over here because I have the only videos that I put, I have seen them for a long time on LinkedIn. And for years, I have seen them grown, like the growth of their CEOs and also their companies and also their product. That's why I put those robots in my slides, not the robots which are on like a concept phase. The third and the most important part is dynamics and control. So I had a lecturer, or I would say like he's now already a professor. He used to always say that the most important and most difficult part to solve is dynamics and control. And why it's more difficult, it's not only like mathematics. Now you have to combine the mathematics with a lot of computer coding skills. And there people sometimes use MATLAB for it. And right nowadays people are using other softwares. ROS is mostly used now for understanding robotics, navigation, or like manipulation problems. Now here I will show some challenges. The first challenge is like modeling. The first one is here, the modeling friction, inertia, and backlash. So there are a lot of friction. We know that we usually avoid friction. We try to guess that, okay, let's say the friction is 0. Let's assume that and start our math. But in the real world, we'll not be able to do that. We have to take account all of the physical constraints like frictions and uh, any noise that are in place. There is also inertia and also backlash. Backlash, if I inertia is very easy, you guys know that inertia is uh like one of the Newton's law, that if an object is not like is at rest, it will resist to go into motion, and if our object is on motion, it will resist to stop. So those things are also there in robot. Like that's why we need a minimum amount of power to start with. And the backlash problem is that happens in the gears. Like if there is a bit gaps in the gear, it's very hard to track that how much the robot has moved. So when we are trying to make it more precise, like we want to know that the robot has moved that much millimeter, but for that backlash issue, we might get an error every time. So that's why it's very difficult for us to overcome this challenge. I attended one seminar. That seminar was only about the backlash thing, and they were the providers of I would say motor drive for the antibiotics company, the company that I showed making the robot dog. So for that company, they are providing the motors, and they say that it's very hard for us to solve the backlash problem, but there has to be some kind of backlash, and that's why it's very hard to achieve that 100% accuracy, that there will be some kind of uh, errors in place. So you can imagine how much precision our human body is working with. Like whatever we want to achieve, we can do it. Sometimes, yes, we get nervous and our hands are shaky, but still, like our human body has been programmed or designed in a really unique way. And there are other problems like disturbances. So the disturbance, how to make it stable, like when there is a disturbance, like let's say drone is flying in the air and it gets exposed to a wind, very strong wind. And at that time, it has to take that external disturbance into account, and it has to still like continue a stable flight. So those kind of uh, things they need to forecast before even like launching the product. Like our product might work really well on normal circumstances, but whenever there is like a disturbance like wind or anything different scenario, then how the robot will perform, that determines the robot's I would say like how much design challenges it has overcome. And also the actuator response tuning, that's one of the problem. Like I didn't want to put this over here, like, but still this picture was a bit fascinating, so I just put it over here, like to show that there is a lot of response problem that we find in actuators. Like we try to move it, but just like our legs, whenever we want to move it, we can move it. Like we have a very small response time. But in robots, that's not the case. There is sometimes needed for like understanding the what like the action. So in the that humanoid robot video, you guys understood that the robot was a bit slower to understand the thing that he said, and then he was acting, but it was a bit slower. That was the problem. Like the response problem is something that robotics researchers are working on. And also real-time motion safety consent. Like the robot can move and do its work, but if someone like a human being is coming in between the robot action, now how the robot will react to it is very important. Like we can make a really cool robot, but if it doesn't have the safety in place, the robot will become really dangerous. So in the below, I have said that if the control is unstable, the robot becomes dangerous. So it has to be noted. And lastly, the software and AI challenge. Right now, everybody is familiar with AI. So I have like said like what AI problems we already are facing is that like there are some uh, similarities with AIs that we are using right now and the AI that will be inside the robots. But in robots, there will be a lot of different challenges. One of the biggest challenges is that in software, what we write, like in our chat GPT, whatever we are writing, the robot, that software is getting that feedback. But when a robot is moving, let's say it's seeing a glass in front, just like the number one. So the the glass will have a refraction. That means it will see something over here, but in actually it's on a bit on the right. And we know that as humans because a glass has a reflection and there will be some kind of changes, but that robot will not know that. So those kind of things under lighting variation or noises, uh, that is very evident that the robot will not perform at its best. So that's also a very big challenge that we are trying to overcome. Some of the robots are trying to have like night vision cameras as well, and so that it can operate on darker environments also. And the second one is a very big one. Like people has invested a lot of research time on this, like sensor fusion. So a lot of different sensors are like fused, are not like they are fused physically. Their data collected is fused, and the equations that we use are fused together so that we can uh, predict where they are right now located. So let's say one example would be that we are taking our GPS data from satellite, and also we are taking our data from his own sensors, like how the motor was moving. We are calling that encoders. And if we merge them, we are getting somehow a correct data that at this point where my robot is. And that data is very important because if I don't know where my robot is located, I will not know that how the robot should move to go to his goal. So that's why sensor fusion is a very big research problem that we are facing right now. The last robot that we made, our main problem, we were stuck with the sensor fusion. So it's really tough. And the third one is like high compute load for real-time AI. So right now we can integrate ChatGPT. That's very easy because once we have internet access or once we have uh, the ChatGPT integrated on the robot, we can directly use ChatGPT or other generative AIs in our robot. But there are really big security concerns. Let's say if I'm using a robot and if it's accessing the internet or the cloud, I would say anyone can hack my robot and that robot can kill someone. Like it can become murderous. And that's a very big problem. And people won't at one stage, people will understand that I will not connect my robot to my internet because we know that it's very easy to hack computers, right? And there is a lot of hackers that will challenge us within 5 minutes. They can hack our uh, computer. Like, however, we like have how much security protocols we have. So once we face that issue, keeping a robot alongside us will be really dangerous. We'll not want to keep something that much dangerous, which can be hacked and that thing can like brutally punish us or kill us. Will not be wanting that. So at that phase, people will start making the hardware like efficient enough so that we don't have to connect it to the internet. And once we don't connect it to the internet while operating, no one can hack us that easily. So for that, that robot needs to have his own AI, and that AI needs a lot of hardware, and that time it will need a lot of different GPUs, maybe like 10 to 20 GPUs one robot will need. And that's why the biggest GPU company, NVIDIA, they are working on making robot GPUs smaller and smaller, so that once we can have like 10 GPUs inside this much size that can be used in a robot, and it can have its own AI, not using AI from the internet. Uh, I think I'm not am I going too fast, or is it like understandable?
It's very, very understandable
Okay.
from our participants, but
Okay. Thank you. Thank you. Thanks a lot. So the fourth thing is that hardware interface for navigation and manipulation. This one is also one of the biggest problem that we faced in our robot was that like we had a lot of different hardwares and it has to be mapped into a like I would say interactive like a robot environment where we can code the robot. So in our case, we are using ROS2. So I think some of the guys who knows the ROS or ROS2 or like robotics, they will be familiar with how difficult it is to make the hardware interface on ROS2. So here, like we had like small problems, but that problems when it was not solved, we couldn't like go in ahead. Like we were stuck at one point for like half a month. So that's how big it is. So that's why I want to show that this is also one of the challenges while we were facing while we're like developing the software or robot. So here in that robot, like we were using this picture is showing that a mobile robot also using a robot arm. So that's very difficult because you also need to understand the mobile robotics, also the arm robotics. So two things together. So the tough part ends here. Now I'll show something easier. Okay, the lecture is almost over. So let's take a breath and first digest what I have already showed. So here in this slide, what I'm showing is that so a lot of people are trying to forecast the future. Nobody knows what the future has, but people are forecasting, some are forecasting so that his own growth or his own company's growth will be there, but some are giving some prediction based on data that we have seen over the last 50 years or 100 years. And now we have AI models. We can talk to AI models, and nobody can directly fool us by giving just a number, right? So let's say even what you see over here, like 1 billion robots by 2035, it might seem fake. So if we go back and search on ChatGPT, we can instantly understand if that prediction is something really uh, uh like I would say unreasonable or is it reasonable. So if there is actually whatever he's saying, if it's actually correct, then what is it what's in it for us, for people attending the class, or even for me? So that's what I want to show, that right now we have these three choices. So ladies and gentlemen, how we can be the part of this robotics business in the next 10 to 20 years. So I have put all of our choices like that we can actually have. Now here, I didn't bring all different types of robot because that's not what I'm trying to talk about, but I'm trying to talk about that how we can get involved in the robotics business. either we make a business which do some kind of dealership, like we buy robots from someone else and we sell it in our locals. And when there is a demand and when we can sell it, maybe we can make profits from it. Or we make a startup. So a startup is also a different topic already. So when I actually got this call for this lecture, I talked to Clara about like we can have more two other classes like where I can teach how to build a robotic startup and another like what we can do to become a robotics engineer, like a different session. So Clara said that yeah, we can do that. Like we can talk within that lecture. But here these two parts I would say that I have a little bit of knowledge because since I am running my own robotic startup, my robotic startup is helping other robotic startup to build their robotic startup. So my startup is kind of like a service based startup. And so what people generally means by a startup is a product based startup. So here in this picture you can see the figure. Do you remember that humanoid robot on that YouTube video performing those tasks? So this guy has made this robot figure, and right now the valuation is over like almost like $39 billion, and it's just starting. It's not even like in the midway. So when it's on the midway, I think it will already reach $1 trillion valuation. So you can see that robotic startup will is growing right now, and it will grow over the next 10 years. So someone making a robotic startup, if he already has that knowledge, will leverage a lot in this robotics industry. But someone even like doesn't have any robotics knowledge, only has some business knowledge, he can start a dealership. He can understand that what kind of robots are currently people will solve people's problem. Right now in our countries, I think it will match to the countries where you guys in. Like they are using these cleaning robots, and they're shipping this from China in a very small price, and they are selling it in a higher price margin in their natives. And that's how a lot of cleaning is done right now in our like countries, because the way we are like hiring maids has becoming more challenging day by day. So when we are in a really tough situation, we need this kind of robots. So there are some general purpose robots that will already get inside our life in the next 3 years. And in the next 3 years, this robot dealership business will be really high, I would say. And someone trying to make a startup will need to face a lot of difficulties. But after 3 to 4 years of difficulties, they will go into a really good like stage where they can earn a really good amount. But someone who is really young and has that energy, or maybe someone you know, or your son or daughter, or maybe your nephew, they can start pursuing the robotics career from now. And I will, if there is another chance or opportunity, I will share that how to actually learn robotics, maybe leveraging universities like AIU, because AIU, I feel like these universities is a really big opportunity for students to learn from different people and with really different perspectives. It's not like only 10 to 20 lecturers, whole degree. It's almost like maybe 200 people or more than that. Like you get perspective from people. And whoever you feel like that they are legit and we can follow them, and following even 1 to 2 people will give you a really big career high. So the last part I would say is that like whatever you become, like there is hard work, and it's very hard to replace hard work. So I've been working and like investing most of my time in robotics nowadays. So that's why I'm trying to run more this kind of lectures in my local also. So when I was reached for this lecture, all the slide was already almost like 60% there. So I told that, okay, it will not be difficult for me. I can take the lecture, and I can show that what we can do to be part of this robotics industry. So thank you guys for listening till now. Like almost it's been 1 year, 1 hour, and now I can take some questions. I would give the floor to Dr. Velsin, and he can take the questions, and I will answer them.
Much, Mohammed Raj. I'm not gonna make any personal comments because I am thoroughly satisfied with your performance. I have gained a significant amount of knowledge in the world of robotics, and I hope so have you, ladies and gentlemen. You can have a startup, or you can get into robotics engineering. All this within the line up within the concept of the United Nations through their 17 sustainable development goals. The number 9, innovation and infrastructure. Let's get to the questions. We don't have too much time left, but let's afford some of you the opportunity to raise questions. Let's go. Questions, please.
Uh, before saying the question, can you guys
Yes,
also type the question on the chat box so that I'm a bit I can.
wonderful. That's very, very important, sisters. Let me echo or will request from our presenter. Before you ask the question with please, Muhammad is requesting that you type your question in the chat box. So we don't have too much time, but please let's try to cooperate, learn from that increasingly important field, robotics. Ismail, let's see what you have. If you don't write the question, I'll try to relay that question. Go directly into the question, please,
Yes, sir.
Ismail.
Yes, sir. Thank you, sirs. Yeah, good morning, sirs. Yeah, good
Hi.
morning, everyone. Yeah, hi. Yeah, this is my question, sir. What societal impacts arise from combining non-robotic technologies with robotics, particularly in discussions about employment, ethics, and innovation?
Okay, if I were to summarize Ismail Adebola's question, Raj, he is asking what kind of impact can those have into society, especially when we look at the goal number 9 of innovation infrastructure. What kind of impact, what kind of consequence do you or influence do you believe those kind of learning can have onto society? I don't know if I made that clear. Shiraj, it looks
Yeah,
like
can you now
okay.
hear me?
Yes,
Okay.
we can hear you now.
So I will repeat the question for Ismail. So if he say yes, then I would like and start answering it. So
Okay.
what I understand by your question, Ismail, is that when we start bringing robotics to our daily lives, like what good it has, like the impact in a good way, right? You want to know, or do you also want to know what impact it might have in a bad way?
Yeah, the both. And again,
All right.
the way they
Both ways.
combine, yeah, both robotics and the robotic.
Okay.
Or can I say it again? Let me say it again. Yeah.
We
What
got your
societal
point. We
impact?
got your
Yeah.
point.
Okay.
Uh, you interpreted correctly, Shiraj. Go ahead with your response.
Okay. So what impact actually robotics has brought till now is very important to note. Like when we are using robots in our daily lives, it will be totally different because right now we are using robots only in general purpose. Let's say there is a really difficult task that human beings are feeling not all right to do it, then it is doing that those tasks. Like let's say cleaning solar panels. Like we have been designing solar like panel cleaning robots for a long time. Let's say there are a lot of solar uh, panels, or I would say like the farms of solar panels are rising right now. A lot of people are going to renewable energy. Now cleaning these solar panels by human labor is really difficult. So yeah, still people can do it with human, but in countries where human labor is not that much cheap, they tend to use robotics. And robotics, using robotics is not like it's very cheap and we use robotics. But the one benefit I would say is that we don't have those people doesn't have to deal with people anymore. And it's very hard to digest this fact that once I was working with a CEO and he told me that people are very difficult to handle. Like when we want 10 people to come here at 10 a.m., it's very difficult to bring them here to 10 a.m. or 9 a.m. So when they're employing robots, they don't have to think of that. Only if there is some maintenance issues, they have to take care of it. But robots will be really easier to employ.
All
Just
right.
like, yeah. So
Thank
in that sense, employability will decrease. There a lot of people will lose job, but I would not say that just people will lose job. People will become more careful about how they do their job. They will not become more reluctant. They will try to compete with robots and they will try to prove that no, they are better. Just like right now, a lot of people are doing in the age of Chat GPT. Like the Chat GPT works really fine, but still we have our human touch, and that's how we're still being employed.
Correct. Thank you very much. Gentlemen, we don't have too much time as I just said. We're gonna try questions. Participants do not have a long question uh, clear to our presenter, Jean Ronald. Let's go very quick, please, and directly onto the question.
Yes, thank you for giving me the opportunity to ask this question. And thank you, Dr. Mohammed, and then thank you, Dr. Valsen. What is the main goal? What is the main goal behind the robotic system? What is the main goal? I don't know if you hear me well.
Yes, we can hear you, Professor Shiraj. What is the main goal of robotics? If I were to answer my
So the main goal of
question,
robotics,
correct.
the main, yeah, the main thing that robotics want to achieve is that we give away all the dangerous and difficult tasks to robots, just like things that humans, when they are doing that, human has to take a lot of life losing risk. So we don't want that. We want robots to take those kind of risks. Like let's say a firefighter is going and trying to fight the fire in a really dangerous situation, and that time he's taking a huge risk of his life, and we want robots to go there and handle that situation. Similarly, in a lot of uh, difficult situations where armies or like
Yes,
soldiers are trying to take a life losing risk, but that time we want, let's say, robots will go and do the thing that that person would have done.
that makes.
So that's like to simplify.
Last question, Santam Duganda. Go ahead, brother.
Yeah, yeah, Mr. Wasim, good afternoon for everyone there. I know the man is very intelligent. Every day we work to reduce our difficulties. My question is this moment, I long for two times. Is it possible to send a robot at the bank to pick up the money So to you withdraw the money, I like the dog to send the robot to market to make something for money. That is possible for a long time.
Okay, I don't know if you get the point, Shiraj. The question from Duganda is whether we can use robotics, for example, to market, to do certain tasks,
Bank,
the world of finances, for example, marketing, advertisement.
Uh, did he actually mean marketing and advertising, or like in the market, the robot will go and act as a salesman? Is it something like that?
Is that what you mean, Santam, for a robot to go and act as a salesperson?
thank you.
Okay, I don't have a follow-up from Santam, but that's about the point. So
Okay,
let's,
so I'll give both answers, if
all
even
right.
if like there are two combinations. So first question is say that, let's say if I want to be like a sales, like if I want the robot to be a salesman, yes. The answer is yes. People are using nowadays like robots that are acting like a salesman, and it in that robot body they are showing whatever the things are available, and like if people think that okay, I need that object, I need the grocery over there, where should I go? Then it will guide him, or it will just say that follow me. If you are not feeling well, I will take you to that place. And in other way, robotics doesn't have to be always in physical form. Like right now, robotics we are talking about in physical form. And if we talk about just the software part of robotics, we can understand that most of the thing can be done by the app. We can order our groceries on the app, and then a robot, they will use a robot to deliver us that thing. Let's say it can be a drone delivering us a pizza. So, so that's how we can do the shopping if the shopping was also intended to be done by the robot.
All right, thank you very much. Brothers and sisters, that's the world now. It's pretty much like 100 years ago, and this today everybody is using the internet profitably. And we are now talking about internet. That's going to be very, very common of robotics. So let's all get involved somehow and prepare getting equipped. Each and every one of you for today. Learn significant. Our presenter, Mr. Muhammad Al Faisal Shiraj, he is kind enough to not only have prepared that, but also have his own personal can copy that and eventually shoot him a question, send him and take additional time to you real quick for your conclusion at this time, please.
Okay.
All
Okay,
right.
thank you guys. Yes, and I'm really pleased that you guys were here. And I'm also like I have also enjoyed this session. And thank you, Dr. Velsin, for like making it more easier for me to take this lecture.